In today's class, we will discuss about the experimental proof of DNA replication as semi-conservative mode of replication. We are all knowing that semi-conservative stands for preservation of the two polynucleotide strand of the parent DNA as 50% and the other strand as the new strand. So 50% of the DNA strand of parental DNA will be conserved and the next 50 will be the new one. That is why we call it as semi-conservative mode of replication. And in 1958, Mathew, MESSELSON and STAHL, these two scientists proposed an experimental proof to show that the DNA replication as semi-conservative mode of replication. Let us see what these two scientists have done for giving a solid proof of semi-conservative mode of replication. They had taken a culture medium in which E. coli bacteria were grown. This E. coli bacteria were grown in a medium containing ammonium chloride. Ammonium chloride they had taken as the medium in order to provide nitrogen bases. Nitrogen is selected as the heavy isotope of the nitrogen, N15. So N15 is providing the nitrogen bases like adenine, thymine, cytosine and guanosine. So every 20 minutes the E. coli undergoes replication or E. coli undergoes multiplication. So for that multiplication they have to synthesize DNA or they have to replicate DNA. So for that purpose they will absorb this N15 isotope of the nitrogen from the ammonium chloride medium. So here we are seeing that the E. coli are having red color DNA which is labeled with N15, the heavy isotope. And they have isolated this N15 DNA strand. And in the next step, they had selected a density gradient centrifugation method. In this density gradient centrifugation method, they can isolate the DNA presence in bands. In the centrifugal tube, they will take a medium with cesium chloride. Cesium chloride is very convenient for separating the DNA based on their size, shape and density. So in this particular case, they are seeing when the density gradient centrifugation with the help of cesium chloride were used, they could see that being heavy, the nitrogen containing N15 containing DNA were deposited at the bottom. At the bottom they have seen the band. You can see a red color band at the bottom and being heavy they have settled at the bottom. So they have found out all the DNA strands were labeled with N15. In the second step, what they have done is that they have transferred some of the DNA from the first step to the second setup where the beaker is containing light isotope of nitrogen, that is N14. You can see here N14. This N14 is mixed in the medium in the form of ammonium chloride. Here the difference is that instead of N15 of the first step, they have selected N14. You can call it as normal isotope or the light isotope of nitrogen. And they have given 20 minutes to replicate. After 20 minutes, they have seen that the nitrogen, 2 E. coli were produced from a single parental E. coli, and when they had isolated the DNA, they could see that out of the 4 strands of the DNA, 2 were the parental N15, that is in red color. 2 were parental N15 and the other 2 strands were the new N14. So please mark it as new 50% are coming as new N14 and the 50% is coming as the parental N15. In the same way, they have isolated with the help of cesium chloride density gradient, and they could find out 2 bands. They could find out only 1 band at the middle. And this band was showing both N15 as well as N14. Since both nitrogen isotopes were found, they have given us hybrid. This nitrogen is hybrid nitrogen isotopes, and this hybrid nitrogen isotopes were settled at the middle side or middle band. So from this you can understand that this has got a mixture of N15 as well as N14. Now they have again retained the same N14. They have added only ammonium chloride with N14, no more N15. When again 40 minutes passed, that means 20 more minutes were passed, they could see that the E. coli is continuing its multiplication, and they could see 4 DNA strands. Out of that, 2 were hybrid. Out of that, 2 were hybrid, and this 2 strands were hybrid variety, and this 2 were the brand new N14. And they had undergone the same cesium chloride centrifugation, and in this centrifugation method they could isolate 2 bands. One is the hybrid band at the middle and the other is the light normal N14 band at the upper side of the centrifugation tube. From all the 3 steps, we could make out that the type of DNA replication where 50% is concerned and the rest 25 plus 25, that means again the 50 are coming as the new. So this will throw a solid proof to the mode of semi-conservative method as mode of replication as purely semi-conservative mode of replication. And this experimental proof by Mathew, MESSELSON and Franklin STAHL was again supported by another scientist in the same year. His name is Taylor. And his experimental material was faba beans. When he analyzed the faba beans and its chromosomal constitution, he could see that suppose this is the chromosome. Chromosomes also will be undergoing replication. So by replication, the chromosome had replicated into 2. In that, he had used the radioactive thiamine. Thiamine was radioactively labeled. we could see that half of the chromatids, out of the two, half of the chromatids were showing the radioactive thiamine. So Taylor, by using Faber beams, also could support Mathew, MESSELSON and Franklin Stahl's semi-conservative mode of replication by analyzing the chromatids which were labeled with the thiamine, radioactively labeled thiamine. So from these two experiments, we can clear-cut prove that the type of replication in DNA is absolutely a semi-conservative mode of replication.